All right, well, welcome to another tutorial where we'll be creating some image-based lights. So we'll take two different approaches to do this. The first approach will be generating an IBL from a series of photos taken from an environment. And the second approach we'll use is maybe a bit less conventional, but we'll actually create a 3D scene with some light sources, some visible light sources, and actually render out an equirectangular image. We can actually do this right inside of Maya, so kind of interesting. We will take a look at that approach second. All right, so first things first here, we'll be using a set of images. So I just picked a room and set up a tripod with my camera. And you can do this with any DSLR or mirrorless camera, anything where you have the ability to set your exposure manually, and of course have the ability to have the camera set up on a tripod so that you can keep it in the same place. You don't want to have the camera move between these different images that you take. So let's just take a look at the photo set to make sure we understand how this works. So I'm taking portrait photos on the tripod, and I only did actually a bracketed set of 5 photos, right? So you'll see that there are 5 photos here for each orientation of the camera. The first one being normally exposed, or exposed according to what the meter on my camera was telling me, and then we're doing +1 stops. Or +1 EV if you want to look at it that way, +2 EVs, -1 EV, and -2 EVs. So just going up 1 stop and then 2 stops of exposure, and then the same thing, but underexposing the photo. So yeah, 5 photos per set there. That was actually a pretty bad, look at that. I don't know if that's showing up on the video, but that's a pretty bad movement. That looks like I was jiggling my tripod when I took that photo there. So hopefully that doesn't turn into an issue when we stitch these photos together and generate the IBL. But little errors like that shouldn't be too big of a deal. But yeah, that's the general idea. Of course, we have discussed the whole idea of creating a high dynamic range image from low dynamic range images. This shot out the window is a perfect example of that, with normal exposure being right around here. At least we're exposing for the inside or the interior. Overexposing, well, blows out all the details. There actually isn't too much more detail to be revealed by overexposing the image, but of course underexposing does start to reveal some of those details outside the window. And I guess also makes my cat's white fur a little bit less blown out, right? We want all those details like the cat's fur present in the photo. So that's what we're going to achieve by underexposing the photos, and just bracketing to get all of the necessary details there. All right, so again, just a couple more details about obtaining the photo set. You want a good overlap of imagery between each orientation for your exposure sets. So, taking a look at this photo compared to this photo, there's a lot of commonality here, such as the edge of the curtains, the cat, the chair. There's a lot of overlap, and we are going to need this overlap here in order to in order for the software that we use to be able to stitch together these photos and create the equirectangular image. All right, so that was a 360-degree rotation to get us those bracketed sets at eye level. But that doesn't really give us very much of a vertical field of view. Our horizontal, or the resulting horizontal field of view, will be 360 degrees. However, vertically, just look at one of these images. that is not very much information from a vertical standpoint. So what you're also going to want to do here is go right ahead and angle the camera upwards towards the ceiling. Do that set of bracketed photos again, all the way around. And then we're going to finish off by angling the camera downwards. All right, so this finishes off the set of images pointing upwards, and then we angle downwards and do the same thing here. All right, so that, again, it's not quite 180 degrees in terms of a vertical field of view. We are missing a little bit of information on the top and the bottom, but for the practical purposes of creating an IBL, you will be able to get away with this just fine. And it's not like the information, farther down and farther up that we're missing here is going to contribute all that much to the lighting effects given by the resulting IBL. All right, so that is my photo set there. I do have 200 images, right? So with the 3 vertical orientations, or the 3 camera tilts that we're using, and 5 images, five exposures for each image, that is giving me 200 images here, depending on how much you rotate the tripod or how far you pan between each set of images. You may end up with more or less images in your photo set. So to create the equirectangular image, I'm going to use a free program called Hugin. Works fairly well. So you can head on over to the Hugin site and download a copy for your system. You can grab your Windows and your Mac installers and go ahead and get that installed. And when it is, we'll be able to launch that and have a new project open here. If your interface doesn't look like this for some reason, it might be on a different setting. So we're just going to revert back to the simple interface view here. And we will see right up here on your top left, easily accessible, will be the Load Images button. So we are going to start the process and load in a set of images. And I'm going to navigate over to my set of images here. I have a raw folder with all of my raw images in it. I always want to keep these separate from the final panoramas that we'll be creating here. And I'm just going to go ahead and select everything and go ahead and open those up. Now, Hugin is actually a fantastic tool. It's got a really nice feature in here where it actually can recognize when you have what it calls image stacks. So, I mean, it explains the scenario here. It explains, if we read this through, that when shooting bracketed image stacks from a sturdy tripod, the position of the images in each stack can be linked to help Hugin process the panorama. But if the images in each stack require a fine tuning of position, if you were shooting this handheld or something like that, then don't link the position. So, I mean, I've tested this already, and I know that if I link the positions for each of my images, each of the images in these exposure stacks, things will work out just fine. So I'm going to go ahead and link position, go ahead and get all those images loaded in here. And we're going to see that Hugin automatically detects some useful information, such as the focal length that was used for these images. Actually, that detail escaped my mind. I should have mentioned that back when we were talking about the image sets. So my apologies, but yeah, this is definitely an important piece of information here. The reason it took so many images and the reason I wasn't able to pan very far between each set of images was because I actually only have an 18 millimeter lens. That is the shortest focal length lens I actually have. But then again, all the better to do the example using an 18 millimeter lens. as I know that perhaps if you're not much of a photography enthusiast and you only have like a stock DSLR with whatever lens it came with, you're far more likely going to have something like an 18 to 55 millimeter lens, something like that. Of course, if you have a lens with a shorter focal length, you're definitely going to want to use that, and you'll be able to get all the information in far fewer images. But yeah, yet again, another reason to do the example with a commonly accessible lens focal length. So we can see that there. That has been automatically identified from the information associated with each photo. All right, so that's all in there, ready to go. I'm going to go ahead and hit the align button. This is going to automatically run through your image set and position everything so that we can have all these images stitched together as a 360-degree panorama. Now, this is probably going to take a while, so I am going to go ahead and use the magic of video editing to make that process a bit shorter. We'll come back when it's ready to go. But one other detail, just before we do that, is for the situation where this process doesn't work out all that well. So as we saw when Hugin popped up with that little dialogue asking us if we wanted to link the positions of these stacks of images, there are tools inside of Hugin to actually line up images yourself if you need to. So that's one thing you can do. But in practice, if you're expecting your workflow to work a certain way, if you want to avoid a lot of manual fine-tuning where you don't know how much manual fine-tuning might be necessary to get your image set working the way you want it, in practice, you might actually find a lot of the time that it is easier and quicker to just go back and make a clean image set, right? And retake your set of photos. So just a suggestion, if this step doesn't work out, you can always go back and create a new set of photos. You're just going to have to think about it and think like, what's the trade-off here? What is faster? Do I do a bunch of manual work, or do I go ahead and put in the time to get a better set of photos? All right, so we'll come back in just a second and take a look at the panorama that has been stitched together. Again, this is only an internal Hugin process. We still have to make some setting adjustments to decide on what sort of panorama we want to export. So we'll do that in just a second here. All right, so with those images stitched together into a panorama here, we're going to find Hugin switching over to a different interface here, just showing us the stacks of images that it was working with. We can see some control points that were added here, which is related to which images were connected with which. You can also see these stack numbers. This is kind of interesting to see. Just the 5 images per stack. You can see those all listed on the side. And other than that, we should be good to go here to head right over to the Stitcher panel. We can see some default settings already set here by the program. We'll see that it's recognized that our horizontal field of view will be 360 degrees, so that's great. We know that at the very least we are creating an image spanning that horizontal field of view. It's found the vertical field of view to be around about 140 degrees. Again, like I said, we can get away with that for practical purposes of creating an IBL. Projection, we're going to want to leave this on equirectangular. That is the type of image we want to create for use as an IBL. We can see that the final image size here is going to be about 17,000 pixels across, 6,000 pixels tall. So we can resize that later on if we need to. That'll be quite sufficient resolution. And let's take a look at our panorama outputs. So it's going to be the panorama outputs that we're most interested in here for creating an IBL. We are actually going to start by just quickly creating an exposure corrected low dynamic range image. So we'll switch the file format over to JPEG, and let's just start. Let's just test the image set to make sure it works. This process will be a little bit faster than actually creating the high dynamic range panorama. So we will want to do the quick test, generating just a normal low dynamic range JPEG, just showing us the final panoramic image. So with exposure corrected, low dynamic range, JPEG selected, let's go right ahead here and hit the stitch button. All right, so this should ask us that, where do we want to save the file, just because this does need to be saved before we can continue the process. So let's just go ahead and do that. I'll put all my files into my IBL folder here. So this, I'm just going to leave the default file name here. This will be just a temporary Hugin file we can come back to if we need to. But this PTO file, that will be the Hugin file. And the second file here is going to be the name of the image that we're going to create. So I'm going to call this LDR test. That will be for the JPEG image that we are attempting to create. All right, so again, we are going to come back in just a moment here after this panoramic has been created. We'll take a look at it, make sure everything makes sense, and then we'll create the high dynamic range equirectangular image that we'll use as an IBL. And with that low dynamic range completed, we can go ahead and take a look at the results here. So taking a look at that image that we just generated, LDR test, it is upside down, but no worries, we can always rotate that in Photoshop later on, but looks good. We can, take a look a little bit closer to see, there will be some issues potentially, like, down here at the extremities of the image, with the table kind of being stitched together in a bit of a strange way. But that shouldn't cause too many issues during rendering. We're mostly interested in the walls looking good, the other objects in the scene looking good. A bit of an issue there. But of course, with a higher quality set of images, these issues can be done away with. All right, but there we have it. There is a low dynamic range test ready to go. Good to just test your photo set to make sure things look good. And now we can set Hugin up to create our high dynamic range image. So we'll just switch this setting over. We'll turn off exposure corrected LDR. We will turn on high dynamic range, and I'm going to export an EXR. I like working with that file format. You can also store high dynamic range images in TIFFs, but we'll use an EXR here. And everything else will stay the same here. We'll go ahead and stitch this as well. And this is going to be our high dynamic range IBL. This will be our high dynamic range image. All right, and again, we'll have to wait for this to complete here, and we'll come back when we are done. So with the high dynamic range image-based light successfully created there, no issues or anything, let's go ahead and take a look at the results. We do have an EXR image created here. Now we will need to open this up in Photoshop, so let's go ahead and do that. I'll drag and drop that I'll drag and drop that image in here. Again, it is upside down. You know what I'll do is I'll also drag and drop the low dynamic range in as well, right? So I'll just bring in that JPEG that we initially created so we can compare these side by side. I will do an image rotation for 180 degrees here to just rotate those two images so that this makes a bit more sense. And let's compare them. Again, we're always going to want to do this sort of exposure test just to make sure that the bracketed photos that we've used are being interpreted correctly and that we are actually retaining a high dynamic range of lighting information. So on the low dynamic range image, we can do we can add an exposure adjustment right on top of the background layer here. And well, again, the test I think we should do for this image is involving this window area. So let's go ahead and drop that exposure down to, let's do -2 EVs. And of course we can see, you know, as expected, just the brightness of the whole image, including these white areas, is just going to get, you know, we're going to start introducing some darker grays, and we just, you know, it's just the overall brightness of the image that has been reduced here. Of course, because there's no more information being stored in this 8-bit sRGB image. For the EXR file for this high dynamic range image, instead, we are going to be able to see some details actually present in those brighter areas. Of course, same thing for the darker areas, but a good, pretty obvious test for this scenario is going to be to check those windows, as I said. So I'm again over on the EXR image. I'm going to add an exposure adjustment, and we can drop this down. We start to see those details come through, and let's just type in the value of -2 just to make it the same as the test we ran on this image. So -2 EVs, and there we go, right? So we can see that this is working just fine. We've got lots of nice high frequency details present in this image. They become visible when we drop the exposure down, and the same would be true for any particularly dark areas, perhaps underneath the table here. Although it looks like pretty much everything is visible at around 0 EVs. Again, that there actually isn't all that much information, extra information to be found in the dark areas of this image. All right, so that'll work just fine for us. We can go ahead and save this high dynamic range image-based light, and just to save the 180 degree rotation we just did there, and we can go ahead and use this image in just one moment when we bring our IBLs into Maya and take some test renders. All right, so before we take our test renders, let's quickly jump over to Maya and take a different approach to creating an IBL. We'll just set up a rather simple scenario here inside of Maya to just get a feeling for how this should work, just to see how to set up a camera to render with an equirectangular lens. And yeah, we'll just take, again, a small number of photos. We'll take like, we'll create like the same sort of bracketed photo set that we saw with the photo interior scenario. We'll just take, 2 brighter images and 2 darker images. We're not going to be super technically precise here in trying to calculate exposure values or anything like that. We'll just do something like this. Actually, you know what? I'm going to take a different approach here. By default, Arnold actually renders your background color, like if there's no geometry, and we just render the background. It actually renders that as transparent. So to skip or to avoid an intermediate step here, in just cleaning up our images or setting our background to opaque after rendering. I am going to just use a cube. Let's edit this a little bit, make it not quite as tall here. Let's do something like this. And then we're going to go to mesh display and reverse to just flip all of the normals on that box, right? So now the inside of the box is has outwards pointing normals, or normals pointing towards us, right? So we can actually do here in display, we can go ahead and turn on backface culling just to make back faces not visible to us. That'll just help us with editing this scenario. All right, so I'm not going to be super precise here. We'll just really quickly set up a test scenario. I'll just throw a few geometric details in here. Just so we have something to look at, and so we have something to reflect when we use some reflective materials. Let's make sure that one's visible. Just put like some pillars in here. Okay, so that'll work. And let's also add in just some planes here. I'll drop my subdivisions down because we don't need those. And I'll select that plane again. I'm just gonna hold J and do snap this to a 90-degree rotation and position this plane on one wall of the environment here. We'll do something like this. And we are actually going to use emissive materials here. The reason we're doing this is to have the light sources visible in the final render. And it just makes for a nice way of working with like actual visible lights in Arnold. So with that plane positioned and ready to go, we'll hold right click and open up our context menu and assign a new material. So I'll assign an AI standard surface as usual here. And over in the AI standard surface 1 tab for this object, let's head down to emission, and we'll work with, let's work with a value of 1. Let's see how, yeah, let's just set the emission value to 1 for this image, and then we'll set up a second image-based light. We'll put that over on the other side of the environment. So we'll kind of rotate that over like this, make that nice and big. We're kind of simulating like a really simple studio lighting setup here. You know, or actually now that I think about it, I think we should make the intensity of the other light source a bit higher and make the intensity of this kind of fill light or this softbox, we'll keep that one low. All right, let's do that instead. So for the first light source here, I'm actually going to start with a emission value of, let's just go with 5. And for the softbox, we're going to hold right click, assign new material. Again, this will be another AI standard surface, and we'll set this one to an emission value of 1. All right, so very bright small light sources will be like our hard key light, and then lower intensity large light source. This will act as kind of a nice soft fill light, right? Really simple lighting setup. You could create whatever you want here. All right, so with that ready to go, let's go ahead and add a camera, and we can leave that. It's actually kind of cool that it's pointing the wrong direction. We're going to see in just a second that it makes absolutely no difference what direction the camera is pointing, because we are going to be taking an equirectangular render here. or quite specifically, I should say that we will not be using perspective projection to render this image, but rather equirectangular projection. So that's going to give us information for a horizontal field of view of 360 degrees. So yeah, we will, believe it or not, even though the camera is pointing towards the opposite wall here, we will still be able to see these light sources. Kind of cool. All right, so if we were to head on over to our render view and render through the, actually, we'll need to switch our render over to the camera one here, right? So if you can access the menu set in the render view either by holding right click, or you can just use the render menu up here. But yeah, we're going to go to the render menu, the render tab, I guess, and select camera one here. Okay, so this is a render using perspective projection. And let's see, let's just select, or actually, sorry, we are using camera one here. So with that camera selected, we're going to check our focal length. It's currently set at 35 millimeters. Well, makes sense. We are pointing at this blank wall here with a field of view of 35 millimeters. We are not going to be seeing all that much. But what we will do to get that equirectangular render is go ahead, select camera one again, and under the camera shape node here, we're going to scroll all the way down to the Arnold tab. And we're going to see that we actually have different types of projection we can use for this camera. We could do an orthographic or a fisheye projection if we want, but a spherical projection is going to give us this equirectangular image. All right, so there we go. Like I said, it doesn't matter the fact that this camera is pointing the wrong direction. We will actually be able to see information all the way around the camera, right? So that full 360 degree horizontal field of view. Let's make a few changes before we start creating our renders here. I will head over to my render settings, and in the common tab here, I'm going to set my width and height for the final image to let's go with a 4096 by 2048 image. It's always a good idea to work in powers of 2, and this the aspect ratio for an equirectangular image should be properly, it should be 2:1. So let's go with that for the width and height of the final image. And under the Arnold render tab here, we'll bring our camera samples. With diffuse and specular at 2 samples, we can bring camera samples up to, or let's see here. This will take a little while to render. Bring it up to 6. That should clean up most of the noise. We'll take a look in a second. But we can also drop down transmission, subsurface scattering, and volume lighting to 0s because we're not using those effects in the render. All right, so we'll make this as efficient as possible and go ahead and render that image. And this might take a while depending on your computer. But yeah, we'll come back when this image is done rendering. All right, so still a bit of noise left there, but I don't want to wait any longer for these renders, these 4K by 2K renders. So I'm going to go ahead and just save the image. We will be saving the color managed image. By default, Maya will have this output mode set to the raw image. We want to save this we want to save our low dynamic range images in sRGB. So go ahead and switch this over to color managed image. And I'm just going to go ahead and put this over with my raw images for the IBLs. All right, so I'll save that in there. I'm going to choose PNG for my file type, and we can call this. Now we should name these so that we remember what EV number in our bracketed set this corresponds to. So I'm going to say image EV0, and then we'll use like 1 or -1, 2, -2 to just label the various images there. All right, so that should work for us for one of those images. You can confirm that it has been saved correctly. Again, if you don't select that color management option, this will come out very, very dark as it was saved in the wrong color space. So, all right, so there's one low dynamic range image. Let's work with this. Let's change the light intensity values, right? So we're just gonna change light intensity values on these two materials here for these emissive objects, and use that as a way of kind of creating the idea of different exposures for these renders. So let's see here, let's just select, should label these. I'm going to call this key light and fill light. So for my key light, let's go for the higher exposures here. I'm going to, let's see, I will double that intent, or I'll go up to, yeah, sure. Let's just double that intensity. Let's just double all our intensities just to keep this simple. So that'll go to 10. This one will go to 2. All right, so 10 and 2. Let's go ahead and render that. And with another image finished off here, let's go ahead and save that one. This will be our, let's just call this +1 EV. Again, we're not going for technical accuracy here, but we'll consider this to be just a +1 and save that one out. And then get started on the next image. So we will, let's, we doubled from intensity of 5 to 10, so we can go up to 15 on the key light. We doubled that, so let's go, we went from 1 to 2, so let's add the same amount again. Let's go up to an intensity of 3 on our fill light here and render that out. All right, another one done and ready to save here. This will be, let's treat this as our +2 EVs. All right, so we'll get that one saved off, and we'll go in the opposite direction now. We'll take our key light, right? This was originally at 5, an emission weight of 5, or its light intensity was 5. So we can have that. Let's start by having that light intensity. Again, this doesn't have to be super precise. We'll drop that down to 2.5 there. Take the fill and drop that to 0.5. Or actually, just thinking here, let's get a different range of values. Again, I'm not being super precise here. Maybe we'll drop to 3 on the key light, and I don't know, like 0.7 on the fill. All right, so we'll go with those values, render this out again. All right, save that one out. It'll be negative EV, let's call this EV -1. And we'll finish it off, again, not being too technically precise here. Let's drop the key light down to, I don't know, like 1, a weight of 1, and about 0.3 for the fill, and render that out one last time. So this will complete our 5th image and give us a good set of a good bracketed set of images to use to generate this IBL. And again, we're going to take a different approach to construct the IBL here, right? We don't need to worry about stitching together individual images into a panorama, as of course rendering from Maya has already taken care of this process, rendering as an equirectangular image. But what we will do is, of course, to create that final high dynamic range version of these 5 individual low dynamic range equirectangulars, we'll just use Photoshop's merge to HDR feature just to finish off the IBL itself. And that finishes off the last image here. Let's go ahead and save that one. This will be, we'll call this our -2 EVs, and bring these all over into Photoshop. So over in Photoshop here, we can just, we don't need to open up any files. We can just head straight to the Automate tab and choose Merge to HDR Pro. We're going to browse for these images, and I'm going to find these in my raw folder. This set of images, doesn't matter what order we import them in, we'll be able to assign which image corresponds to which EV in just a second here, but we will hit OK, bring those in, and Photoshop is just verifying that they are properly aligned. Of course they are, yeah, in a second this will pop up with the options to manually set our EVs. We're going to do this through EV values, not through like a shutter speed or aperture values. So we'll switch this radio button over to EV here, and just go through these one by one and just assign, based on the file names, assign what EV each image corresponds to. So -2, all right, so this will be -2, this was +2, this was -1, +1, and finally EV0. So I'm just going back through, make sure those are all correct. Don't want to make a mistake on those values, right? So those are all set correctly. We'll hit OK and get this preview. We can, yeah, there's no ghosts here to make much of a difference, so we don't need to turn that on. But we can just verify that the EVs are, again, corresponding to the right images down on the bottom here, +2 all the way down to -2, and go ahead and hit OK. So that'll create the 32-bit image. And let's go ahead and save this as an EXR. In my final IBL folder here, we'll choose Open EXR, and this will be our, I don't know, I'll call it our CG IBL, computer generated IBL. Go ahead and save that. And well, we're not going to need that anymore. We can just check to make sure this looks good, right? So dragging and dropping the EXR file in here. Again, we can do our test with the exposure adjustment, just seeing how the lights behave, seeing that we have nice details. Of course, anything beyond, really beyond +2 EVs and -2 EVs, we are going to start losing detail. We don't have any images associated with those exposure values. But yeah, no, this looks good and will be sufficient for our purposes. Again, definitely a lot of noise present in these renders here. I just didn't feel like waiting longer for Arnold to churn out a cleaner image. All right, but that'll work just fine for a computer generated, like a rendered IBL. All right, so with that out of the way now, let's head over to Maya and do some test renders using these IBLs we've just created. So with a new Maya file ready to go here, let's go ahead and just create some spheres to just as some test objects to render out here. I'm mostly going to be interested in fairly reflective materials here. So with an AI standard surface, we can for this first material here, we can keep the roughness fairly low. Actually, I'm going to go with a value of around 0.3. That'll work for a nice glossy dielectric. I'll duplicate that object, right-click, assign new material, another AI standard surface. This will be a metal, and we'll drop the roughness to, let's say, 0.15. That should look good. All right, so there's our two test materials. And, well, let's add in these IBLs using an Arnold sky dome light. All right, so under the color texture input or attribute input for the sky dome light, we can hit that checkerboard and bring in a file node, and then we're just going to select. Let's first select the. Let's first go ahead and select that IBL we created from the set of photos. So that will be, make sure you select the EXR. We don't want that JPEG image in here. That is not an IBL and will not work for our purposes. Let's go ahead and bring in that HDR IBL file. And we will have to wait a moment here for that to be added in. Notice how the color space has automatically been set to raw because, of course, this is not an sRGB image. It is stored in linear color space. We can see a preview of the IBL here in Maya. And let's go ahead and take some test renders. So we'll switch back over to our render view, and we can go ahead and hit render here and see what we get. Now this is going to take a few moments the very first time we render with an IBL, especially one of this size, because Arnold does create this temporary .tx file. In fact, we can see that being generated on the side here, right? Arnold has generated this .tx file. It's just something that Maya does to kind of pre-process your textures to make them a bit easier to work with. So well, let's actually see here what the file size was for this IBL, right? That was 270 megabytes. That is a very large texture that we're using. So this is going to take a few moments the very first time we render to just do that pre-processing on the texture. All right, and with that out of the way, we have our final render here. So let's frame up a nice shot. Let's do something like this. We can see what that looks like. All right, I'm actually going to adjust the materials a little bit. I want this dielectric to be a little bit more reflective. I think maybe the value of 0.2 actually will work quite well there. I'm actually going to, let's see, 0.2 on the metal as well. Make that a bit more glossy. There we go. Very, very nice. In fact, let's go even more reflective. I would like to see those reflections starting to come through. There we go, on the dielectric as well. So that will work quite nicely as some material tests there. Always a great idea if you want to test out what your, the color and lighting information your IBLs are contributing to the scene. Always a good idea to just throw in some different test materials there, especially reflective ones, which will start to show off the environment and everything, all the information that is going to be reflected by reflective objects, right? We want to see that environment information come through. Something else we can do here in case we don't want to be distracted by the background is to just head over to the visibility tab of the IBL and just turn off this camera attribute. Just bring the value down to 0. That will prevent us from seeing that background image, and we'll only see the rendered image objects themselves. All right, so that looks really nice. We can see all the color and lighting information coming through from the real world environment. Let's go ahead head back over to the file node for the IBL itself, this sky dome light, and I'm actually going to select the computer-generated IBL. So we'll bring that one in. Definitely, we can see that noisy background coming through, but it shouldn't prove to be too big of a deal. What we're mostly interested in is the color and lighting information. So a scenario where you might use where you might want to create a computer-generated IBL and use such a thing would be just for setting up a really simple studio light setup, right? I mean, of course, you could go ahead and set up a bunch of area lights to kind of mimic this sort of environment. But hey, what if you didn't want to waste any time creating any geometry for an environment or setting up the lighting? You could just use something like this, which would you could just add in a single IBL, and there it is, right there. There's a lighting scenario. It's as easy as just adding in a single sky dome light, connecting in that IBL. No more work required there, and we're ready to go. All right, definitely a weakness in this example is the amount of noise I left in those renders. It's definitely not helping the clarity of the reflections, but that can of course be addressed just by letting Arnold render for longer and cleaning up all that noise in the image. All right, so there's two different approaches for creating IBLs, and yeah, so specifically kind of the interesting nuance there. Again, I don't see this approach talked about very often. The whole idea of creating IBLs from computer-generated environments, but definitely a very viable choice with quite a few use cases, especially for like test renders and stuff like that. All right, so thanks for sticking with me through this tutorial. Hope you learned lots, and we'll see you in the next one.